another trainML tutorial. trainML is a GPU as a service platform specifically designed for deep learning. Our platform lets you get up and running on GPUs with just a few clicks without the need for managing servers, learning a new framework, or enduring a lengthy software implementation. In this tutorial, we will walk through how to deploy an image classification endpoint on the trainML platform. We will use a VGG16 model from Keras Applications with the ImageNet weights and configure it to accept a new image submitted inside of an HTTP post request and return the top 5 predicted classes and their confidence scores as the response body. Let's start by reviewing the model code we will use to set up the endpoint. All the code is contained in the predict.py file of the repository. The predict_image function is where the actual inference occurs. It takes the name of an image file that must exist on the local file system as the only parameter and returns an array of the top 5 predicted classes for the image with their confidence scores. Since our endpoint will be accepting a JSON payload for inference, the model code must be able to translate the allowable JSON data types into a data format that the model is expecting, which, in this case, is a binary file on the local file system. Binary data is not permitted in JSON, so the most common way of sending binary data in a JSON payload is through base64 encoding. Since this model code and the predict_image function is also used for automated batch inference, we cannot change the function itself. Instead, we can create a helper function called predict_base64_image that takes a file name and the base64 encoded image as parameters. This function creates a temporary file, writes the decoded image contents to the file, and runs the predict_image function on the temporary file, returning a dictionary with the name of the file and its results. Using this function, the same model code can now process endpoint requests as performs batch inference. As our batch inference will use the main loop that runs when the file is executed as a script, and our endpoint will import and call the predict_base64_image function directly without executing the main loop. Now that our model code is ready, we can go to the trainML dashboard and click Deploy an Inference Endpoint. We'll call this Image Classifier Endpoint and select RTX 2080 Ti and configure our image classifier model code repository in the Model section. The key concept with endpoints is routes. If you are familiar with Flask in Python or Express in Node.js, trainML endpoint routes serve the same function. They simply map an HTTP request to your backend model code. They instruct the endpoint web server that when an HTTP request using a specified verb is made to a specified path, then run the specified function and return the function's value as the response body. To add the route for our image classifier, keep post as the HTTP verb and specify /predict as the path. Specify the name of the file in our model code, predict.py, and the function in the file we want the web server to call, predict_base64_image. Since this is a POST request, we need to configure the format of the expected request body. This must match the parameters our function expects. Since the function expects 2 positional parameters named name and contents in that order, we will add 2 parameters, name and contents, and keep the function uses positional arguments checked. Both parameters are strings since image contents will be base64 encoded, and neither is optional. Click Next to review your configuration and Create to deploy the endpoint. Once the endpoint is running, click Connect to view the endpoint base URL. To use the endpoint, we need an HTTP client that can send a base64 encoded image in a JSON document. The tutorial code repository contains 2 examples of how to interact with the new endpoint. The first example, using the curl command, is found in the classify_image.sh script. We can run this script with the endpoint URL we got from the web interface and the location of a file that we want to predict. The curl command then prints the inference response to the console. The second example is using a React frontend. To configure the React app to use your new endpoint, enter the endpoint base URL into the API address attribute in the config.js file. Then navigate to the frontend folder in the terminal and start the React app with npm start. Once the app is running, you can select images from your local file system. The app will display the image, and then when you click the Get Prediction button, it will send the image to the endpoint and record the response to the right. You can continue to upload new images and see the responses as desired. As we've seen in this tutorial, trainML makes it easy to deploy your model code as a REST API with minimal modifications to your existing code and without the need to build a web application, configure reverse proxies, or maintain web servers. If you'd like to learn more, you can check out our documentation site at docs.trainml.ai or shoot us an email at sales@trainml.ai. If you run into challenges running this example or anything else, you can always contact us at support@trainml.ai. Thanks for watching.